Hello class, this is Dr. Fasha again. We're going to talk about chapter 7. For this chapter, we just focus on chemical reactions. The term of reaction just apply for any chemical changes. If you remember from the chapter 3, we have two types of changes, physical change and chemical change. Whenever we say physical change, at the end of our change, we have the same substance. We never make a new substance after physical change. Like the example we reviewed in our class. If you are going to have a piece of paper and fold it, this folding is just make a shape change or size change. We call it physical change. We still have piece of paper at the end. Whenever we say chemical change, after any chemical changes, we have a new substance. So the purpose or our goal in the chemistry is making new substances. So whenever we say chemical reactions, we are going to make a new substance. When we work in the lab, we are going to know how to figure out we have a chemical change. We have a reaction. We have 5 factors or 5 evidence to show us to prove that we have a chemical change. One of those is gas formation. If a seal starts to bubbling, it means we have a chemical change. Another possible way, and this is the most commonly used evidence in chemistry lab, is color change. If we have any color change, it means we have a new substance. We are making a new material, a new chemical. Also, light emission. This is another way we can find out we have a chemical change. And last 2 evidence for our class. I'm going to ask you to pay attention to these 2. One of those is changing of heat or releasing or absorption of heat. If we feel colder or warmer, it means we are absorbing or losing heat. It's same whenever we are working in the lab. When you keep and hold one beaker, if you see the beaker just became hot, it means we are working on one chemical reaction. And the last thing, whenever you add 2 liquid or solution to each other and you make a solid, this is a new type of chemical change. We call it precipitation or forming a precipitate. Precipitate, it means we have an insoluble solid. So precipitation or precipitate means insoluble solid after adding 2 solutions to each other. Before working on chemical change and see how to write them, we have 2 types of conservation laws in the chemistry and physics. Conservation law of mass and also law of conservation of energy. In our class we work on mass. Conservation law of mass says the total mass of substances in a chemical reaction must remain constant. What does that mean? Assume that you are cooking. If you start with some materials and you follow the recipe, at the end you have the same material at the end, but with the new form, with a new shape. In the chemistry it's same. If we start with hydrogen, at the end we still have hydrogen. If we have oxygen, it will be same. We don't make any other element like gold, like silver. So whenever we start, for example, by 100 grams of water as the initial material, initial chemical, we have at the end totally 100 grams for our reaction. It doesn't matter. We break it down to hydrogen and oxygen. Summation or mass of these 2 components should be same like the initial material, 100 grams. So if we have like this equation 100 grams of water, at the end we should have 100 grams. It doesn't matter how much of each one. This combination should give us 100 grams. So we may write law of conservation of mass like this. Mass of reactant, the compounds placed on the left side, it would be same as mass of products, the elements or compounds on the right side. So mass of reactant always is same as mass of product. We are going to talk about chemical reactions. First, chemical equation. Whenever you are going to report a chemical reaction, we call it chemical equation. For chemical equation, we use one arrow to represent a progress of reaction. Any substances on the left side, we call them reactants. Any substances on the right side, we call them products. So based on the definition, based on the convention we have today, left side element, left side compounds, we call them reactants, and on the right side, we call them products. If we are going to follow conservation law of mass, we need to apply some numbers, whole numbers or an integer number, to make conservation law of mass satisfied by the progress or chemical reaction. To do that, we use some numbers. We call them coefficients. I'm going to talk about this by the next slide. Look at this example, CH4 plus oxygen, it gives us CO2 and H2O. Forget these numbers. I'm going to add the numbers here. Based on conservation law of mass, we need to have the same mass on the left side, same mass on the right side. How to do that? We say we are going to use some numbers that we call them coefficients to balance our equation, to find same number of atoms on the left side. On the left side, we have one carbon atom. On the right side, we have the same number of carbon atoms. It means carbon atoms are balanced. Number of hydrogens. We have 4 hydrogen atoms here, and in H2O we have only 2 hydrogen atoms. So I'm going to add manually a number in front of this formula. This number is a whole or an integer number, 2. 2 times 2, it gives us 4 hydrogen atoms. So right now I have same number of hydrogen atoms. For oxygen, on the left side, if we have 2 oxygen atoms here, on the right side we have 2 oxygen plus 2 times oxygen, totally 4. That is why I applied 2. So whenever we are going to solve our problems, we need to have a balanced chemical equations. To balance chemical equation, you need to make same number of atoms on the left and right side. To do that, you need to apply a coefficient. We call it whole number. Also, we have some information on the chemical reactions. One of those is a state of matter. We call them solid, liquid, gas, or aqueous. So if I write compound with parentheses S, it means I'm talking about solid form of that compound. Also, if we use a triangle, this delta means heat. So whenever you have this notation, it means for having this reaction, we need to heat it. We need to use benzo burner or hot plate. Look at this example. I'm going to balance this equation. Question says mercury oxide should be heated based on this notation and gives us mercury and oxygen. We are going to balance this equation. First, on the left side we have 1 mercury, on the right side we have the same 1. So it looks it's balanced for mercury. For the oxygen, we have 1 oxygen on the left, 2 oxygen on the right. Different number of oxygen. So if I multiply this number of oxygen by 2, I have 2 oxygen atoms. So whenever I'm going to multiply that, you should write 2 here. I should write 2 here. If I write 2 here, 2 mercury, we should have 2 mercury as well. So I'm going to balance this. So I multiply that one by 2 as well. So right now I have 2 mercury, 2 mercury, 2 oxygen, 2 oxygen. These numbers, we call them coefficients. And right now, number of elements on both sides of the reaction are balanced. Please pay attention. Always we use the smallest whole numbers. What does that mean? If you multiply the equations by 2, 2 times this number, it gives us 4, 2 times 2, 4, 2 times 1, it has 2. We have 4 oxygen, we have 4 oxygen. We have 4 Hg, 4 H. It looks this is the balanced one, but we only accept the smallest whole number. I may ask you to work on this example. This is an example I give it you to work on this. It looks a little bit complicated when we compare with the previous one, but the strategy and method are here is same as the first one. Look at the compound. This compound reacts with another one to produce these two products. Question says write the balanced chemical equations for this one. First thing, we have 1 magnesium, we have 3 magnesium. So I have to multiply here by 3. So if I look at the multiple choice question like this, the answer for B, possible answer for B is incorrect. So you can easily eliminate that. 3 for magnesium should be written here. Then I'm going to balance another element. Let me work on the phosphorus here, P. We have 1 phosphorus here, but here on the right side, phosphorus in the parentheses, we have 2. It means 2 phosphorus. So it looks I have to multiply this number by 2. Multiply this compound by 2. So 3 for magnesium hydroxide and 2 for phosphoric acid. If we look at the possible answer, so it looks C is incorrect because we don't have 3 and 2. So right now I'm going to balance another element like hydrogen. If we have 3 here, 3 hydrogen times 2 hydrogens, totally we have 6 hydrogen. 6 hydrogen on the left side. On the right side, on the first compound on the left side. On the second compound on the left side, you had 2 here, like this. 2 times 3, 6. 6 hydrogen here, because 3 times 2, 6. 2 times 3, 6. Totally we have 12 hydrogen atoms. So on the right side, we should have 12 hydrogen atoms. So if I multiply that number by 6, it gives us 6 times 2, 12. So it looks this is the last one, only the correct answer. This is the step-by-step strategy we apply. 3 for the magnesium, because we have 3 on the right side. Then the number of elements just change. Magnesium is balanced. I'm going to balance another one. If we are working on the polyatomic ions, you may consider that polyatomic ions like PO4 as one unit. PO4 on the left side here and PO4 on the right side. It helps you to save your time and you don't need to balance phosphorus and oxygen separately. We say 2 phosphorus, 8 oxygen, or you may say we have 2 PO4. So on the right side we have 2 PO4 as well. So this is the one way we are going to work this in our class. You have a workshop, you have a handout, and I may ask you to work on the balancing equation. And another concept we need to work on this in this chapter, we are going to know how many types of reactions do we have. We are going to classify reactions by 6 types. I'm going to explain for you step by step, and after that you are able to see these 6 types. First type we call it synthesize or composition. Whenever you add two elements and make one product, we call it synthesize or composition. How to find out we have synthesize? If you have one product, we call it synthesize or composition. So the way you can get that one is if you have only one product. Another type of reaction, if we have like this general reaction and we break it down to its components, we call it decomposition. What does that mean? It means we start with one reactant and we break it down to more products. How to find out we have decomposition reaction? If we have only one reactant. So two things so far. If we have one product, we call it synthesize or composition. If we have one reactant, we call it decomposition. Another types of reaction, we call it single displacement. Your textbook call it single displacement. If you find in other textbook single replacement or replacement, it will be same. Whenever we have one element reacts with one compound, we call it single displacement. So the way we can get that one reaction between one element like sodium, like Fe, like calcium, and one compound like H2O, like NaCl, when we have compound. When we have two compounds in the left side, two compounds as reactants, we call it double displacement reaction. So in old-fashioned textbook, we are able to have these four types of reaction as the first classification of the reaction. But in advanced chemistry textbook and in modern chemistry, we have two more types of reaction that I'm going to talk about. One of those is combustion reaction. Reaction with oxygen. If one of your reactant like this reported like oxygen, O2, we call it combustion reaction. Combustion reaction is chemical term for burning. Reaction with oxygen is rusting, is tarnishing, is burning. But in chemistry we call it combustion reaction. How to figure out we have combustion reaction? Whenever we have one of the reactants oxygen, we call it combustion reaction. I'm talking about each one in our class, but here composition, combination, and synthesize, they are some commonly used term for synthesize reaction. Whenever you combine two reactants to make only one product, we call it synthesize reaction. They are examples of composition or combination or synthesize reaction. Two reactants or more, they make only one product. One product means this type of reaction. For decomposition, if we start with one reactant, like this example, in our equation, we have one reactant. So one reactant, it gives us decomposition reactions. And for single displacement reaction, I may ask you to notice generic reaction, generic equation. What does that mean? Reaction of element with compound. Whenever we have element and compound, we call it displacement reaction. How to write out the four products? You just need to change the first part of the compound with these elements. A should be written here. Element should be written for the first part of the product. Look at this here. Zinc plus HCl. Zinc is metal, is element, HCl is a compound. Reaction of compound and element. We call it single displacement. How to write the products? This element should be written here. We remove H first part of this compound and we write Zn. How to write out the another compounds, another element for the product? Whenever we write Z in here, H just released. You just need to know that hydrogen exists in H2, one of the diatomic molecule, H2. How to write out the formula of this compound? If you remember that when we have reaction between, if we have a compound of metal and non-metal, we call it ionic compound. Zinc always is zinc 2 plus. This is one of the exceptions and you memorize that. And Cl is 1 negative. Zinc 2 plus, Cl 1 negative. You just need to switch the numbers, switch the charge, and you get the zinc Cl2. Then you need to balance this reaction. 1 zinc on both sides, 1 Cl on left side, 2 Cl on the right side. So I have to write 2 for this compound. 2 hydrogen and 2 hydrogen on the right. So this is a balanced chemical equation for this type of reaction. We call it single displacement reaction. We have more examples that I may ask you to work on this by pausing this video. Right now we are going to talk about double displacement reaction. It looks we have two compounds. To write the products for the compounds, you just need to change the first part of each compound. So you should write A as a first part of this compound and X as a part of the second compound. So you should say X, B, and A should be written here, A, Y. One thing you should pay attention, whenever we are going to work on the double displacement reaction, we need to have two compounds. Whenever we are going to categorize types of double displacement reaction, we may have some subgroups, some experiments, some reactions that we may call them by a specific term, like precipitation, acid-base, and gas-evolving reactions. We may talk about this in our class. Precipitation means we make solid, so one of the products should be solid. Acid-base, it means we have acid, H in the front of the molecule, and base, OH at the end. So this is the one thing that we work on this in chapter 14. And gas evolving reaction, one of our products is gas. So we talk about this later in our class. And last type of the reaction, we call them oxidation-reduction reactions. For oxidation-reduction reaction, we have only new definition. Before talking about the definition, I may ask you to apply the short review or short form of this reaction. Oxidation reduction, we call it redox reaction or redox reaction. We abbreviate it by this. This type of reaction just have a new type of reaction in the chemistry by transferring electrons from one element to another. Transferring electrons. This is totally new. So I'm going to talk about this. Whenever one atom loses electrons, we call it oxidized. Whenever one atom gains electrons, we call it reduced. Let's see what does that mean. Look at these examples. Na, it gives us Na+. It means sodium loses one electron and make cation. We remember that metals lose electrons and make cation. Losing electrons, we call it oxidize. And this reaction, we call it oxidation. If we are going to work on Cl2, it gives us 2Cl negative. So look here, non-metals gain electrons and make anions. So gaining electrons, we call it reduction. So the compound or the element, we call it reduced. How to memorize that? You may look at this cartoon. LEO, losing electron, means oxidation, and gaining electron means reduction. Metals lose electrons. It means metals oxidize. Non-metals gain electrons. It means non-metals reduce. So if we are going to know that what compounds are solid, one compound is gas, one compound is aqueous, we just need to work on one table. We call it solubility table. We have some rules that we are going to review in our class. But one thing that you should know, if we have acids, all acids are dissolving in water. We call them aqueous. If we have elements group number 1 compound, lithium, sodium, potassium, they appear in a compound, they are placed in group number 1. All of them make soluble compound. Soluble means we should write aqueous. We are going to memorize some of the rules in this table. If we have nitrate compounds like sodium nitrate, potassium nitrate, magnesium nitrate, calcium nitrate, whenever we say nitrate, it means we have a soluble compound. We should write aqueous. So I may ask you to work on this example. Which one is soluble in water? We should write aqueous if it's dissolved in water. KOH, K group number 1. Whenever we say element in group number 1, we should call them soluble. So this one is soluble, aqueous. I'm going to talk about this one, nitrate, lead nitrate. We say nitrate. All nitrates are soluble, so we should write soluble here. I'm going to back and talk about the other rules. Whenever we are talking about halogens like chlorine, bromine, and iodine, they make chloride, bromide, iodide. If they pair with silver, mercury, and lead, they make insoluble solid. So if we have silver with halogens, mercury with halogens, and lead with halogens, they make insoluble. Look at this example. Ag with halogens. It means we may have insoluble solid because this is the exceptions. Silver with that one make insoluble. So I'm going to say insoluble. For this one, halogens with calcium, I don't have silver, mercury, and lead. So it looks this is a soluble. I talk about the nitrate atom. We have lead sulfate. Let me back and see what was the rule for sulfate. Sulfates are generally soluble except when sulfate pair with one of these elements: silver, lead, barium, calcium, strontium. So the resulting compound is insoluble. So when we have Pb and sulfate, it should be insoluble. You don't need to memorize all of these tables, but you should know how to apply this information. So whenever we work in our class, we have enough example to make sure that you are able to get the correct answer for this one. And last thing that I'm going to ask you to pay attention, whenever we have two aqueous solutions react with each other. Aqueous means they dissolve in water. Ki, group number 1 element, we should write AQ. NaCl, group number 1, we should write AQ. Whenever we have aqueous, we look at the product side. Aqueous, aqueous. On the left side of this compound, we have potassium, means aqueous, because group number 1 element. On the left side of this compound, Na, group number 1, aqueous. If we have like this, we cannot identify our products. So we say we have no reactions. We say we have no reactions. So like this one, no reaction. How to find out we have no reaction? If our products both are aqueous. If our products both are aqueous, we say no reaction, and we abbreviate it by RXN. NORXN, no reaction. So please pay attention. AKs for the product side, we call them no reaction. It was a quick review for chapter 7. We may work on this chapter by more details in our class. I may ask you to pay attention to the details by watching the other videos. So again, if you have any question, ask me. Thank you guys for watching this video as well.